Hello, this BTEC Sport and Exercise Science video is focused on Unit 2 Functional Anatomy. Now we're looking at the skeletal system, and specifically within that system we're looking at D3, the location of skeletal bones. Now your skeleton is actually divided up into two sections or two areas. This is the first of two videos looking at one of those areas, the axial skeleton. So what do we mean by the axial skeleton? As you can see from this diagram then, the axial skeleton refers to the bones in blue, this central axis of our body. And we'll look at each of those bones in detail in a moment. Just to give context, the other section or area of the skeleton you need to be able to identify is the appendicular skeleton, and I've just color-coded that in red. So all the girdles, the shoulder girdle, the pelvic girdle, and the limbs are the appendicular skeleton. So we've got this axial axis of our body, and we've got these appendages of our body. But this video is focusing on the axial skeleton. So what are the functions of the axial skeleton specifically? Given that it's this central axis there, it has an important role for us. It stabilizes the appendicular skeleton. So these appendages, our limbs, attach to our axial skeleton at our pelvic girdle and our shoulder girdle, and we'll look at those in a moment, in the next video actually. But this is the central axis about which our limbs are attached and our limbs move. Secondly, there's a lot of bones which act as protection for our visceral organs, our important internal organs. Obviously our skull protects our brain. There's a lot of organs inside our thorax, our chest cavity. There's a really important organ going up through the spinal cord. So the axial skeleton and the bones of the axial skeleton are there to protect us. Lastly, some of these bones, for example, all the vertebrae, provide attachment points for muscles. So there's a lot of attachment points for muscles. So I'd say function 1 and 2 were more important than the third. Let's look individually at these, the bones of the axial skeleton then. The axial skeleton is made up of the skull. The cranium is the proper name, and you need to understand that the cranium is made up of several flat bones which are fused together with fibrous joints. Its job is to protect your brain. Then we have the thorax, or the chest cavity, the thoracic cavity. And the thorax involves the sternum, this breastbone, this flat bone in the front of our chest, and the ribs that attach to it. The ribs attach at the rear to the vertebral column, and the front, most of them attach to the sternum. You can see these bottom couple of pairs of ribs don't attach to the sternum, but several ribs do. So the thorax is made up of the ribs and the sternum. Lastly then, our axial skeleton includes the vertebral column. So we have several vertebrae that are in sections, and you will need to know the names of these sections. You'll need to know what type or classification of joint is at each section as well. So for example, the little tailbone that we don't use anymore, it's redundant, is called the coccyx, and that's a couple of tiny vertebrae that have been fused together, 4 vertebrae that have been fused together. Those are fibrous joints or immovable joints. We don't wiggle our tail anymore, it can't move. In the same way, our sacrum, so the 5 sacral vertebrae, are fused together here. This is basically the back of our pelvis. So our pelvis would be here, and the sacrum is the protective back part of our pelvic area. Then we've got the big, thick, strong, chunky lumbar vertebra. There are 5 of those. They have several processes sticking out, which muscles and ligaments attach to. And this lumbar section is big because it's got to cope with a lot of turning and twisting and forces acting through it from our body. Then we've got the 12 thoracic vertebra. Now these are the ones that are at the thorax level. So this is your rib cage level. This is your chest cavity level. And they're at the back of this thorax area actually. They're a bit smaller than the lumbar ones because they don't have to deal with as much movement or stress or impact. And then at the top, we've got our 7 cervical vertebrae. These become smaller and smaller and smaller until we get to the top 2. And the top 2 are very specific. They're called the atlas and axis. Now, we've got these 2 sections down here that are fibrous classification of joint. They don't move. The majority of the rest of the vertebra, all of them in fact, except for those top 2, are cartilaginous joints. They are, and you can just about see the pink colouring there, they have little discs of cartilage between them. I think my next slide gives you a better version of this. Here we go. So you can see this is a vertebrae and this is a disc in between the vertebrae. It's a little bit blurred still, but you can kind of see it. Now these intervertebral discs cushion, they absorb shock, and they're really important. And this vertebra and this vertebra is one cartilaginous joint. Now individually, that joint doesn't allow a lot of movement. It allows a little bit of movement in any direction. But if you add that joint and that joint and that joint and that joint, all the joints of the vertebrae up, you'll appreciate that actually collectively it enables us to move a lot. Okay, so we have got all 3 classifications of joint in our vertebral column. We've got fibrous classifications of joint down at the bottom, those bottom 2 sections. We've got cartilaginous classification of joints from the lumbar all the way up to the cervical vertebra, except for the top 2. We've got a pivot joint at the top, so the atlas and axis actually is a pivot joint. It allows us to sort of turn our head from left to right. That's a pivot joint. And actually, additionally, between these spinous processes, the sticky out processes of the vertebra, we have gliding joints, synovial gliding joints. So fundamentally, the bottom 2 are fibrous, all the other joints are cartilaginous, the top 2 vertebrae is a synovial pivot joint, and additionally, when we sort of do a back bend, all these little processes will slide past each other, and that's called a synovial gliding joint. Each little vertebra that slides past each other is a synovial gliding joint. So as I've said, we've got all 3 classifications. We've got 2 types of synovial joint, pivot and gliding, as I've explained there. The bones of our vertebral column are all irregular. They protect the spinal cord, and they're designed with a hole in the middle so that the spinal cord can go up through the middle of the vertebra, and they allow for muscle and ligament attachments. All these sticking out processes, they stick out at the back and they stick out to the left and right side, obviously not the front. They are what muscles attach to and what ligaments attach to keep our vertebral column really stable. Now, do we have a big range of movement? Overall, as I explained, we combine the movement of all of these small joints, yes, but individually, no. Individually, one cartilaginous joint has very limited movement in all directions. The atlas and axis at the top is a pivot joint which only allows rotational movement in the transverse axis. The ligaments we have attached all the way up and down our vertebral column, and the muscles for that matter, you can see the ligaments over here, they hold the vertebrae together, they stabilize all of these joints and try and keep us sturdy and contained. And of course, just to be clear, there's no range of movement in our sacrum and our coccyx sections because those are fibrous joints. So there's actually a lot of information to learn about the vertebral column. So what I've tried to do then, having gone through lots of detail individually, I've popped a lot of that information into a table, almost like a summary table. So have a little look at this. Make sure you know the names of the bones that are in the axial skeleton and what type of bone they are, and any other additional information about them. But what kind of exam questions might you get? So let's have a look. This is one example that we've had already. So it says, figure 1, this image down here shows the structure of the vertebral column. Identify the regions labelled A, B and C for 3 marks. So it's given you the top section, the cervical vertebra section, and it's asking you what section is A, what is B and what is C. And it's given you the bottom section, the coccyx. So hopefully you would know the answer to that. Secondly, it's asked you for 2 marks. What's the function of the cartilage between each of these joints, each of these vertebral joints? Remember, these are cartilaginous joints, so there are cartilage discs between each joint. So here's our mark scheme. A is obviously the thoracic section, B is the big chunky lumbar section, and C is the fibrous immovable sacrum or sacral vertebral section. Then what's the function of the discs between each vertebral joint? They are there to cushion, to absorb shock, to absorb impact. They reduce friction and prevent wear and tear and damage between the vertebrae. So that hopefully would be an easy 5 marks for you. So we've covered there the bones that make up or that form the axial skeleton, the cranium, the ribs, the sternum, thorax, that is the thoracic cavity, and the vertebral column. And you need to know all those sections of the vertebral column.